Sucrose density gradient centrifugation. This video is provided by Creative Biomart. The content of this video is divided into two parts: centrifugation types and sucrose density gradient centrifugation. We will first briefly introduce the centrifugation types, and then briefly explain the operation process of sucrose density gradient centrifugation. Let's start with the first part of this video, centrifugation types. This section mainly introduces the information on differential centrifugation, rate zonal centrifugation, and isopycnic centrifugation. There are two common centrifugation methods, differential centrifugation and density gradient centrifugation. Density gradient centrifugation can be further divided into rate zonal and isopycnic centrifugation. Differential centrifugation is simple. It performs at different centrifugal speeds to separate particles with different sedimentation coefficients. Density gradient centrifugation is more complicated. It's necessary to add the sample to gradients to achieve the separation of different particles after centrifugation. Here we will give a brief introduction on differential, rate zonal, and isopycnic centrifugations. Differential centrifugation gradually increases the centrifugal speed to perform centrifugation, so that particles with different sedimentation coefficients can be separated under different speed and time. Differential centrifugation is suitable for separating particles with large differences in sedimentation coefficients. First, obtain particles with larger particle size and density under appropriate centrifugal force and time, and then collect the supernatant and accelerate the centrifugal speed to obtain smaller and lighter particles. Differential centrifugation has the disadvantage of uneven sedimentation, and it needs to be resuspended and recentrifuged for several times to obtain relatively pure particles. Rate zonal centrifugation also relies on the difference of sedimentation coefficients of particles in the samples. But the requirement for the difference among particles for rate zonal is lower than that for differential centrifugation. Under a certain centrifugal force, particles with different sedimentation coefficients settle at different speeds in the density gradient solutions, and finally form bands in different positions of the gradients. For rate zonal centrifugation, the maximum density of the gradients is generally lower than the density of the sample, so the bands of samples are formed during the sedimentation process. If the length of time is too long, all particles will settle to the bottom. So the control of centrifugal time is very important here. The gradient solution used in rate zonal centrifugation generally needs to have the characteristics such as good chemical stability, low permeability, high fusion, easy separation, and low cost. For example, like sucrose and glycerol. Rate zonal centrifugation is generally used to separate particles of similar density and different molecular weight, such as proteins. Isopycnic centrifugation separates particles by using differences in their density. This method often uses cesium chloride as gradient. For self-formed gradient, the sample mixed with the gradients, and then under the action of centrifugal force, the particles with low density float up and high density settle down, until all the particles move to the position of the gradient with the same density. The particles form several bands in different positions according to the difference in density. Isopycnic centrifugation has nothing to do with the shape or size of the sample particles, but is closely related to the density of the samples. The maximum density of the gradients is greater than that of the samples, so the samples will not precipitate to the bottom even after a long centrifugal time length. Isopycnic centrifugation is often used to separate particles with similar molecular weight, but different densities, such as nucleic acid and organelles. Next, we will move on to the introduction of the operation process of sucrose density gradient centrifugation. Sucrose is a solution commonly used in density gradient centrifugation. This method mainly includes the following steps: gradient preparation, centrifugation, separation, and elution. Gradient preparation is a key step in sucrose density gradient centrifugation. Solution with 66% sucrose has low water content and can effectively inhibit the growth of bacteria, so it can be stored indefinitely at 4 degrees Celsius. Therefore, 66% sucrose solution is prepared first and then can be diluted to other desired concentrations. To obtain better experimental results, the sucrose solution needs to be filtered and a refractometer is used to verify the sucrose concentration. When using sucrose density gradient centrifugation to separate protein complex, proteinase inhibitors need to be added, and other types of compounds should be added at the same time according to the enzymatic activities that need to be inhibited or preserved. After the sucrose solutions of different concentrations are prepared, the gradients are made by adding a low concentration sucrose solutions first before adding the higher concentrations. For example, if you need to prepare a 10% to 40% gradients, first add 10% and then add 20%, 30%, and 40% solutions successively. It should be noted that when adding the higher concentration of sucrose solution, the tip of a pipette should be placed in the bottom of centrifugal tubes, taking care not to disturb the interface between the layers. In addition, try to use a cold solution to prepare the gradients, and the prepared gradients should be used as soon as possible to avoid premature diffusion of the gradient layers. Gradient preparation can also be performed with the help of gradient forming instruments and the accompanying manuals. And after the gradients are prepared, carefully add the sample solution to the top of the gradients. If the density of the sample solution is close to the density of one gradient, you can mix the sample with the gradient solution before gradient preparation. Moreover, weight the centrifuge tubes with the sample before centrifugation to make sure the weight are balanced. Due to the difference between the centrifuge and the roller used in each experiment, a pre-experiment is required to determine the centrifuge length of time to ensure that the sample does not settle to the bottom after centrifugation. In addition, it's better to measure the sample concentration because it may affect the resolution of the bands. After centrifugation, you can see the samples in the gradients are separated into different bands according to the difference of sedimentation coefficients. After centrifugation, particles obtained from different bands need to be further separated and purified. Separation can be done in two ways. Different components can be separated and collected from the bottom up with the aid of an instrument like a gradient fractionator, or they can be separated and collected from the top down with a pipette. After separation step, the fraction obtained is a mixture of sucrose solution and the particles we need. So elution is required to further purify the fraction. Elution should be performed according to the characteristics of the particles we need, such as proteins. In this video, we briefly introduced centrifugation types and sucrose density gradient centrifugation. We offer products and services on proteins. If you have any questions, please contact us by phone or email. You can also visit our website, www.creativebiomart.net. Thanks for watching.